So today we're continuing our studies with sequences and series and summations. Let's try a couple of warm-up problems to get us going. So here we have the sequence 1, 5, 9, 13. Just like we've done before, we want to try to write the recursive routine, the explicit formula, calculate the 31st term, and find the sum of the first 31 terms. So if I'm talking about the recursive routine, we have to recognize that the first term here is 1. So I've got to figure out the pattern going forward and then backtrack to get our a sub 0. So 1 to 5, 5 to 9, 9 to 13. I know I'm adding 4 each time to go forwards. So to go backwards, I have to subtract 4. So 1 minus 4 would be negative 3. Therefore, my recursive routine would be negative 3, enter, answer plus 4, enter, enter, enter. Now I can use that and morph it into the explicit formula saying any term number, a sub n, can be calculated by following negative 3 plus 4 times n. Therefore, if I wanted to find the 31st term, I could put 31 in for n, follow my order of operations, and calculate its value, which happens to be 121. So if I want to find the sum of the first 31 terms of the sequence, because the sequence is arithmetic, we talked about the pattern that we use to find the sum for our arithmetic sequence. It's the number of terms times the sum of the first term plus the last term divided by 2. Well, I have 31 terms times our first term, 1, plus our last term, 121, and divide that by 2 to give me my answer. That will leave me with 1,891. Let's take a look at another scenario. You have seat 995 for a Paw Patrol Live Heroes Unite concert. There are 65 seats in the first row and 2 additional seats in each successive row. There are 40 rows in the concert hall. Based on that, we're going to see if we can write the recursive routine, write the explicit formula, calculate how many seats would be in the last row, and the total number of seats in the concert hall. So let's have you pause the video and then we'll check your progress. To help you think of this auditorium, I would write the first couple of numbers in the sequence. So we know that row 1 has 65 seats. Row 2 would have 67 seats, row 3 has 69 seats, and row 4 would have 71, and so on. So again, because this is the first row and we write all of our recursive routines and formulas using a sub 0, I have to backtrack the pattern that I see. Well, 65, 67, 69, those are all adding 2. So I have to go back 2 from where I was to write my recursive routine, which would be 63. So my recursive routine is 63, enter, answer plus 2, enter, enter, enter. Therefore, my explicit formula, any number in the sequence, a sub n, would come from 63 plus 2 times n. If I want to calculate how many seats are in the last row, there are 40 rows in the concert hall. So I could substitute 40 in for n and do that calculation. That gives me 143 seats in the last row. So how many seats are in the concert hall in total? Remember our pattern for summations for arithmetic sequences. It's the number of terms. Well, there are 40 rows in the concert hall times the sum of the first term plus the last term. Well, our first row has 65 seats. Our last row has 143 seats, and then we'll divide it by 2, which would give me 4,160 seats total in the concert hall. Now, to describe the location of your seats, you could get creative with that by tracking your totals row by row. You actually would be in row 13, 7 seats in from seat 1001. So to summarize, what are the big ideas that we've been working with? Well, we've been talking about how to write our arithmetic sequences in our explicit formulas, but the biggest takeaway that we've been practicing since our last lesson is doing a summation. Remember, the sum of the arithmetic sequence is the number of terms times the sum of the first term plus the last term divided by 2. So we have the meaning here in words, and we also have our summation formula here. We also want to remember that the summation for a sequence can also be used with your sigma notation. And so we're talking about, if I see this, it's saying, hey, remember we want the sum of their series of numbers that we're working with. So sigma notation, it's summation notation, telling you to do the same thing that you did with your pattern. So let's try a couple more and see how our summation skills are going and actually writing them in sigma notation. So here we have the sequence 5, 7, 9, and so on up to 19. I want to write the recursive routine for this sequence. And again, our first term is 5. So I have to recognize the pattern and go back to get our a sub 0. So here it looks like we're adding 2. So if I go back 2, I'm starting at 3. So I've got my recursive routine. I can very easily turn it into the explicit formula saying for any number in my sequence, how can I find its term value? Well, that would be 3 plus 2 times n. Could I find the summation of this series? Sure. I know that there would be our first term here and our last term here. The only thing I don't know is the number of terms. I've got to calculate that. So I've got to figure out what term number is 19 in my sequence. So to help me do that, let's try to write the sigma notation, because once I find the top part of my notation, what term number 19 is, I can find my summation. So again, my sigma notation always starts with n equals 1. If you're typing into class kick, do not put any spaces into that section for your sigma notation checker. Here's our rule of how we calculate the values for our sequence. And we've got to figure out, well, again, what term number does 19 represent? Well, if you recall, 19 came from that pattern 3 plus 2n. So if I undo this, that will tell me the term number 19 is in my sequence, so I could finish my sigma notation, and I also can finish the calculation for the summation of the series. So if I'm undoing this equation, I would subtract 3, because I see the addition of 3 to each side, and then I would have to divide by 2 to get my result. So again, subtracting your 3, dividing by 2, n equals 8. So 19 is the 8th number in our sequence. So 8 terms is what I'm using to find my summation. So now I can put the 8 here and finish my calculations to get my sum. And so that would be 96. So again, in order to get the summation of the series, I had to figure out what term number 19 represented. We just undid the pattern, and again, that's your upper part of your sigma notation. Let's try one more. Here we have this series of numbers, and again, we want to write the summation notation and calculate the sum. So again, we're going to look at the pattern. Here's our first term 3 and how it changes 8, 13, 18, and so on to 98. So here it's still arithmetic. I have a common difference of 5, but again, we write everything based on our a sub 0. So if I'm going forward by adding 5, I'm going to have to go backwards and subtract 5 to get my starting amount. So in doing so, I know my a sub 0 is -2, and I have my addition of 5. I can use that to put it into my explicit formula. And I know if I'm trying to write my summation notation, that's the pattern. I'm starting with the first term, but I'm going to have to figure out what term number 98 is in my series of numbers, my sequence of numbers. So again, 98 came from our pattern, -2 plus 5n. We're going to undo this to see what term number that represents. So I see this subtraction of 2. I'll add 2 to each side. I see this multiplication of 5. I'm going to divide by 5 on each side, and so I've got my 20. So I know the value of 98 is the 20th term in my series of numbers. And again, series because I see the pluses in between the values instead of commas, which would be a sequence. At this point, I can finish my summation notation, right? I'm starting with term 1, going to term 20, summing those values that come from this pattern. So 20 terms times the first plus the last divided by 2 will give me my total, and that ends up being 1010. So at this point, you're going to try some practice problems. You're going to find the summations of the series, and then given the series of values, can you write the summation notation that looks like this and also calculate the sum? This goes along with the class kick, so you can type in your values to check. You also have jumbled answers that do not include sigma notation attached to the last page of your packet. Until tomorrow.